So in this video, we will be deriving the expression for velocity of a wave. You can take for that case either a transverse wave or a longitudinal wave. So to visualize a transverse wave would be good. So let us say this is the undisturbed water surface. When you throw stone here and the ripples are formed and traveling. And what is the speed with which these ripples are traveling? Suppose if you look at the top view, here if you throw a stone, the ripples will form and travel like this. So from here, the disturbance is traveling this way. From here, it is this way in all directions. So this particular portion is what we have seen here. So speed, if you want to calculate, we already know that speed is distance by time. Distance by time. Suppose if you want to find the speed of the wave is distance traveled by the wave by time taken. So speed of a wave is distance traveled by time. Here let us restrict something. What is the distance traveled by one wave? One wave means the distance traveled by one wave, the length of one wave. Distance traveled by one wave is actually length of a wave. Distance traveled is equal to length of the wave. Length of the wave is called a wavelength. Length of the wave is also called wavelength. So to produce one wave, time taken by the source is time period. We already discussed in the previous video. If the distance is equal to wavelength, that means time taken to produce one wave is time period. In that one time period, only one wave is produced. That one wave traveled only the length which is equal to wavelength. So when the distance is equal to length of the wave, time taken is time period. Time period. So wavelength is given by the letter lambda, time period is given by the letter capital T. But we already know that frequency is 1 by time period or time period is 1 by frequency. Hence, this can be written as lambda times 1 by time period, because lambda by t is lambda into 1 by t and lambda into 1 by time period is frequency. So if speed of a wave is referred by the letter v, v is equal to speed of a wave. Here speed of the sound is equal to lambda into f. When you multiply wavelength and frequency, we get the speed of sound. So speed of a wave or here sound equal to the product of wavelength and frequency. So wavelength should be in meters. So wavelength is usually in meters into frequency is in hertz. But we already know that hertz is 1 by second. Hence this hertz can be replaced by 1 by second. So it is meter per second. So we already know that the unit of speed or velocity is meter per second. By multiplying wavelength and frequency, we are still getting meter per second. Hence, it is agreed dimensionally. That means unit wise also it is in agreement. So we derived it, but we are just checking whether unit wise it is okay with it or not. It is okay with it. So how do we apply this? Suppose a source produces a sound of frequency 17 hertz. A source produces a sound of frequency 17 hertz in air. What is its wavelength? What is its wavelength? This is the question. We know that velocity equal to velocity, or you can even call it speed now. Speed is equal to the product of frequency into wavelength or wavelength into frequency. What is asked? Wavelength is asked. Keep wavelength here, bring frequency on this side. When you bring frequency to this side, then the frequency comes to the denominator. So speed by frequency is equal to wavelength. Hence, they said it is produced this much frequency in air. Speed of sound in air is speed of sound in air is 330 to 340 meter per second. If it is not given, if no value is given, just take 340 meter per second. Substitute the corresponding values, you will write it. So this you can, a equal to b means b equal to a. So we can write lambda equal to speed by frequency. Speed of sound in air is 340 meter per second by frequency of the wave is 17 hertz. 17 hertz. All the units should agree with each other. Be very careful about it. Lambda equal to 340 by 17. So I will write one more step here, so that it will be easier for us to understand. So lambda equal to 340 meter per second means meter second power minus 1 whole divided by 17 hertz. We know that hertz is equal to 1 by second. 1 by second means second power minus 1. So this is 17 second power minus 1. This minus 1 and this minus 1 will be cancelled. This 117s are 17, 217s are 34 and 1 0 is there. So the wavelength here is 20 meters. So length of, if the frequency of the source is 17 hertz and it is produced in air, then its wavelength in air is 20 meters. That's how we have to make use of this speed relation with frequency and wavelength.